Okay, today's topic is surjective functions. So, let's look at a couple of functions here. So, if you remember, a function is a rule, I'm going to call this one F, that sends every element in a set to one and only one element in some other set, or the same set. So I'm going to do A, B, C. This is called the domain, this set is called the codomain, and so I'm going to define this function just by saying where each of the elements in the domain gets sent to. So I'll say define F by defined by F of 1 equals A, F of 2 equals B, F of 3 equals B, and F of 4 equals B. So there's a function, and it is a function. You can check to see if it's a function to make sure everything in the domain gets sent to one and only one place in this second set, the codomain. And that's true. So I have 1 getting sent to one place, 2 getting sent to one place, 3 getting sent to one place, 4 getting sent to one place. Now, several things get sent to B, but that's okay. So it's okay to send more than one thing to the same destination, but it's not okay to send one place to 2 different destinations. So let me define another function. I'll call it G. Same domain, same codomain, defined by, let me do G of 1 equals A, G of 2 equals B, G of 3 equals C, and G of 4 equals, let's do A again. Okay, so this is also a function, and we know it's a function again because everything in the domain got sent to one and only one place in the codomain. This function G differs from F in that everything in this codomain has something sent to it. So if you look at the image of F is equal to just the set containing A and B, whereas the image of G is equal to all of the codomain. So this function G is called surjective. And this is essentially the definition of surjective. A function is surjective if its image is equal to its codomain. This is also known as onto. So the definition: a function is surjective if its image equals its codomain. So if we do, say, F from A to B is surjective if the image of F is equal to B. So that's what we're going to use as the definition, is that the image of the function is equal to the codomain. What it means, sort of casually, is, like I said before, everything in the codomain has at least one element getting sent to it. So this function G is surjective, and it's okay that more than one thing gets sent to A, just so long as every element in the codomain has at least one thing getting sent to it. So there's no like orphan elements in the codomain like here. C doesn't have anything sent to it, so that function is not surjective. Okay, so let's look at some examples. Make sure I get this in the right spot. Okay, so let's define a function P from the reals crossed with the reals to the reals defined by P of, let's say, xy is equal to x, that is. So here we have our domain as a Cartesian product of the reals with themselves. The domain is the Cartesian product of the reals with themselves. The codomain is the reals. So if you wanted to send an element of the domain to the codomain, like say, for example, P of 1, 2 would be equal to 1. And P of pi e would be equal to pi. And P of 1/2 7 would be equal to 1/2, and so on. So you take an ordered pair from, like, the plane, a point in the plane, and it gets sent to the x coordinate of that point. This function is onto, or surjective, because you pick any element in the reals, so you could give me any real number, like -37, and I could give you an element in here that gets sent to it. So for every element in the codomain, you can find at least one element in the domain that gets sent to that element. So it is surjective. So there's one example. Another example, the identity function, I'm going to call it I, from any set to itself defined by, if it's the identity function, you take any element in A, you apply that identity function, and you get the same element back. This certainly is surjective. Now it would be tough, I guess impossible, to give an example like I did up here of applying that function to something, because we don't know what the domain and the codomain are. So, but this fairly intuitively is surjective, because anything in here that I want to figure out whether something in here gets sent to it, well, if I take an element A in A, or an element B in A, then that same element A or B is going to get sent there by the identity function. Let's do a function we're all familiar with next. So we'll do f from the reals to the reals, defined by, let me do a familiar one, f of x equals x squared. So how about this one? Surjective, not surjective? I'm giving you a second to think about it. This one is not surjective. How do I know? Well, because I can come up with a lot of elements in here, and I don't need a lot, I only need one. So I can come up with an example of an element in the reals that has nothing sent to it by this function. So if I want to justify this, -1 is in the reals, but there is no x. So that f of x is equal to -1, because that would mean that x squared is equal to -1, which we know does not happen in the real numbers. So there's no element in the domain that gets sent to -1, or negative anything else for that matter. So this is not surjective. I'm going to double underline the not, and this one is surjective. Okay, so that's a familiar function. Let's do one that's probably a little bit less comfortable. So another example. Let's do, what letters have we done? P and I and F, so let me do G. From the integers to the integers, defined by G of n is equal to, I'm going to do a piecewise function, n plus 2 if n is even, and 2n plus 1 if n is odd. Is G surjective? So this is a video now, so Maybe I should tell you to pause the video and think about it for a few minutes before I attack it. Okay, so now I'm assuming you've paused the video and you've decided for yourself whether this is surjective or not. And so I'm going to try to figure it out myself now. So one way to do this is kind of brute forcey. So you could do like a table of values. You could pick some n's and do like a table of values like you did in junior high school or something. You pick some values from the domain to plug in, like 0, 1, 2, 3, 4, 5, and plug in and just see what happens. See if you can get a feel for this function. So now it's a piecewise function, which depends on whether the input is even or odd. So if n is even, 0 is even, 2 is even, 4 is even, what you do is you add 2. So 0 is even, so the function value g of 0 is going to be 0 plus 2 is 2. 2 is even, so you plug in 2 into this function, you're going to get 2 plus 2 is 4. We're right down to 2 plus 2 is 4. You plug in 4 in, you're going to get 6. If you were to plug in 6 in, you'd get 8, and so on. And so it looks like certainly we can get all of the even numbers out. So, you know, if any even number I want to get out, I would just plug in the even number before it. And I probably should have gone down with some negatives for the inputs. But you can imagine going down lower in the left-hand direction. Now, if you plug in odd values, you're going to be using this second half of the rule. So 1 is odd, so g of 1, since 1 is odd, is going to be 2 times 1 is 2 plus 1 is 3. And if I plug in 3 in here, 3 is also odd, so I'm going to get 2 times 3 is 6 plus 1 is 7. So that's interesting. I've missed 5 here, and let me just plug in 5 just to complete my table. So you plug in 5 in here, you get 2 times 5 is 10 plus 1 is 11. So I've also missed 9. So if you look at this rule, this is going to give you even functions out, or even values out. This is going to give you odd values out, but it looks like we've missed 5 here. So it looks to me like this function is not surjective, and that there's no way to get 5 out. So my question is, can we get 5 from this function? Or a better way to say that probably when we're looking at surjective is anything sent to 5? So in order to get 5 out of here, we'd plug 5 equals 2n plus 1, and you'd get n equals 2. In order to get 5 out of this, you'd have to plug in 2, but you don't plug in 2 n equals 2 in here because you're only plugging in odd n's in here. So this function is not surjective. Because nothing gets sent to 5. Now, nothing gets sent to lots of other things also, but in order to not be surjective, there only has to be one thing that doesn't get sent to something in the codomain. So that is not surjective. Okay, so that is surjective. So what I'm going to do is I'd like to do a proof that involves surjective functions, but I think this is probably enough for one video, so I'm going to stop this and do a separate video with a surjective proof.